So welcome back to another video in our statistics series. So today we're going to be taking a look at measures of location and spread. So this is the second chapter normally in year one stats that most people cover. And it's not too difficult a topic because a lot of the stuff that you'll cover in this chapter you might have seen before. So things I will look at in this chapter will be stuff like the mean, the median, and the mode, which you'll have seen many times before. We'll just look at a few ways to do some calculations on this and the kinds of questions you can expect. Apart from that, we'll take a look at something called percentiles and deciles, and you'll probably know a little bit about this. It's quite similar to things like the median, but the median, is in the middle. Percentiles and deciles are just looking at all the other parts in between. So we'll take a look at that as well. Then apart from that, we'll take a look at things you already know about as well, like the range, interquartile range, interpercentile range, and so on. So these topics will be fairly simple and you'll have known a lot of it from like your past studies in GCSEs. Then apart from that, there's a few new things we'll take a look at in this chapter as well. So things like variance and standard deviation, which you want to get used to since you'll be using this quite a lot if you carry on with statistics or even in the second year. And finally, we'll end with coding, which normally people find quite difficult, but as a concept it's not too bad. So we'll eventually get to that. So there's quite a lot of calculations in this topic, so we'll try and go through a lot of the different ways you can solve the different types of questions, and hopefully by the end of it any type of exam question or question for each of these should make a lot more sense than it normally does. So to start off with, let's just take a look at the mean, the median, and the mode. So before we get into that, actually, we need to know about something called a measure of location. And what is a measure of location? Well, it tells you basically where a value is in a data set. Now, it doesn't tell you about anything else. It just tells you, in a data set that you have, where is that value going to be located? Is it somewhere in the middle? Is it somewhere at the beginning? Or is it somewhere at the end? And then going from the measure of location, we kind of go into this thing known as the measure of central tendency. And this basically tells you a bit more information. It tells you exactly about where the center of the data is. So it tells you a bit more information about, where the center of the data might lie. And the things that you've learned, things like the mean, the median, and the mode, all of them try to tell you something about where the middle of the data lies. And there's different ways of figuring this out. That's what the mean, the median, and the mode actually are. So let's take a look at our data set here. So if we're doing something like this, so something like the measure of location might tell you about where this one's located or where this one's located or where this one's located, but a measure of central tendency might tell you a little bit more about this piece of data or these sets of data, something more about where the middle of your data is actually going to be. So that should be fairly simple. And apart from that, let's just talk a little bit more about the mean, the median, and the mode in case some of you haven't done it so much. So really, really quickly, when we're talking about the mode, if I have a set of numbers, the mode is the value which will occur the most. So let's say something like I had the numbers 1, 1, 2, 2, 3, 4, 5, 6, 6, 6. So the number 1 has occurred 2 times, the number 2 has occurred 2 times, 3 occurred once, 4 occurred once, 5 occurred once, but 6 occurred 3 times. So 6 here is going to be the mode. So that's the mode for this one here. Now, when you're doing questions like this, there's also something known as the median. So when you're doing something like the median, you want to figure out what is the middle number. So to do this, if you count this, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. Oh, my bad, it's 10 numbers there. So if you have 10 numbers, what you want to do is you want to basically count which one's the middle value. So let's just say I added another number here, which is 6. That would mean I had 11 numbers here. So to find the median, I'd say I have 11 numbers, and you always add 1 and divide it by 2. And this tells me the 6th one is the middle number. So I count 6 long, so 1, 2, 3, 4, 5, 6, and that's the median. And as you can see on the other side, there should also be 6 numbers, 5 numbers, 1, 2, 3, 4, 5 here. So it's 5 on this side, 5 on this side. That's your middle value of 4. Now, let's say we went back to the previous situation where you had something like that, and instead you had 10 numbers, then you'd say 10 plus 1 over 2, which is 11 over 2, which is 5.5. So this means take the 5th and the 6th number and average them. So the fifth and sixth numbers would be 1, 2, 3, 4, 5, 6. So these two would be our fifth and sixth numbers. And then what we'll do is we'll do 3 plus 4 is 7. 7 divided by 2 is 3.5. So that's going to be your median value. So that's just a quick recap of stuff that you'll already know at GCSE. So hopefully you're already familiar with that. So moving on from that, let's take a look at how we can calculate the mean. I've only done the mean in the mode above. That's because I wanted you to show you the formal way that we normally do the mean. So before we go straight into calculating the mean, let's actually talk about the equation for the mean. So the equation looks something like this, and we call this the sum of x over n. Now, what does that actually mean? I'm sure a lot of you are taking a look at this and have seen this symbol here. And if this is the first time you're doing this chapter, then this symbol will be new to you. And what this symbol here means is it means to sum off. And what this means is you add up all the values of x. So if, for example, if I had a data set which was like 1, 2, 3, 5, 7, then the sum of x would be 1 plus 2 plus 3 plus 5 plus 7. So that's what the sum of x would be. So it'd be something like 18. So that's how you can find out what the sum of x is. And n is the total number of numbers you have. So actually, if I go back for a second, x here, like you can see, was 18 if you summed it up. And n would be how many numbers we have in total. So it'd be 1, 2, 3, 4, 5. So 5 would be what n is. So if I did 18 over 5, which is the sum of x over 5, then that would actually give me what the mean of this set of numbers is. And actually, that's quite simple. I was going to do a calculation for the mean, but that's kind of it as well over there. So I'll do an example after this as well. So yeah, so basically, this is the sum of values of all values of x over the total number of data points, and that's how you can find something like the mean. So let's say I wanted to do a question based on this, and a bit harder than just finding the basic mean from what we've done. Let's say I gave you a question where I said, if I had a sample of different numbers, and I said from 25 numbers, I found that the mean of these 25 numbers was 5.5. And let's say from another set of 25 numbers, so let's put that in the first set, from another set of 25 numbers, I found there were 35 numbers. And the average of these 35 numbers was something like 7.3. And then I said, I put these two numbers together. So now that I've got these numbers together, what is the new mean of both of these sets when I add them together? So let's think about what this really means for a second. So I've got two data sets. So what I need to do first to figure out is I know that the sum of x over n is going to equal to my mean for everything. So let's start with the easy part. So what should n be? Well, I have 25 numbers here. I have 35 numbers here. If I add these together, that will give me my value for n. So I had data set number 1 had 25 numbers, this is 35. Put them together and you'll get a total of what your new data set should have. So here we can see it should be 60. And how did I get that 60? I did 25 plus 35. So that's the easy part. Now I need to find the sum of x. So how can I find what the sum of x is for both of these numbers? Well, let's take a look at them separately first. So this one here, if I say I already know the mean is 5.5 using the equation. So I'm just using this one here, this equation here. So I'm saying I know that the mean is 5.5. I don't know what the sum of x of these numbers are yet, but I know in total there are 25 numbers. So if I just do some simple algebra, 25 times 5.5 should equal to my sum of x. So based on that, let me just take out my calculator and calculate what is 25 times 5.5. That is equal to 137.5. So that's the sum of all these numbers. And it kind of makes sense because this is kind of saying that in a way that I've got 25 numbers and each of those numbers is 5.5. So I'm just seeing what the total is. Now, if I do the same thing here, I say 7.3 is the same as sum of x, which I don't know. Let's call this one the sum of y, divided by n, which in this case is 35. Then the sum of y should be equal to 35 times 7.3. 35.7.3 in my calculator, 35 times 7.3 is 25 or 255.5. So now I know that these are the two sums. So up here what I do is I actually add up these two sums together. So plus 255.5. And then this will give me another number, which I can divide by 60 to get my mean. So 137.5 plus 255.5 divided by 60 gives me 100. Oh, not that makes sense. Divided by 60. Yep. So actually, let's try to get my calculator. Equals to that divided by 60. Okay, equals 6.55. So that's what the average of all these numbers together should be. So that's basically how you do it. And also, how did I get this number here? Well, I did the sum of x plus the sum of y. It might be a better idea if I call this the sum of z. Say it's the sum of all the numbers. But essentially, what did I do? I found the sum of x from here and found what these are, found the sum of y, found out what these numbers add up to, and then just add up all of that, divided by 60 because there's 60 in total, and that gives you the new average, and that's probably the easiest way for you to figure out averages and the such from these kinds of questions. So hopefully that makes some sense, and that's pretty much it for that style of question that you'll have. So before I move on, we'll talk a little bit about how you can do the mean for frequency tables. But before we do that, what I wanted to do was talk a little bit about, the different measures, the mode, the median, and the mean. Like, which one's the best to use in which situation? Because they're all measures of central tendency, but they're all good in different kinds of situations. So the mode is usually quite good when you have like qualitative kind of data, or if you have quantitative data, you only really want to use it when you have a single kind of mode. Because if there's one example where something is chosen the most, then you probably want to use that. So it's quite useful in that case. Or if you have like two modes, it tells you that these are the two most popular kind of things that you have. So something like if your graph looks like that, or your graph looks like that, you can say that these are the most popular points. So the mode tells you something about that. And it's not very useful if each of your values only occur once. So if I had like 1, 2, 3, 6, 7, something like that, then all of these values occur once. The mode would not really tell me anything, to be honest. And so when do we use the median the most? So median is good as quantitative data, so numbers, and it's usually quite good when you have extreme values, because extreme values tend to affect your mean. And what I mean by that is, imagine I had like 1, 2, 3, 4, and like 500, and I told you to find the mean of that. The mean of that would be quite large, and that would be affected because the 500 is quite large, and that affects the rest of your data. Whereas if I found the median of this set, I'd have only 3, which is a lot more representative than whatever the mean would be with that 500. So the median is very good to use when you have extreme values. Just keep that in mind as well. And finally, the mean is very useful for quantitative data, where if you have data which you use every single piece of data and to measure it, so it kind of gives you a true kind of measure of the middle value. But it's affected by extreme values, so you kind of have to be careful with that. But yeah, I hope all of that kind of gives you a quick primer into the mean, the median, and the mode. So what I want to do now is I actually kind of want to go into how we can solve this when we're doing a frequency table. So you obviously learned that the sum of x, the mean of x, which we write like this, by the way. Notice I've had a bar. That bar means the mean of x. If you put the bar over anything, like a bar, b bar, that means like the mean of a or the mean of b, and so on. So this means the mean of x. So mean of x is equal to the sum of x over n. That's what you're used to learning from the part we just did. So how do we do it for a frequency table? So this is the kind of thing you use when I used to give you 7 numbers, like 1, 3, 5, 6, 8, something like that. And I said, find it for me. But sometimes we're not given data in that kind of form. Sometimes you're given data in a frequency table. In that situation, what you do is you use, again, the mean of x is now the sum of x times f over the sum of f. So don't let this kind of put you off if this whole sum notation and all of that. I'll give you an example of how this works when you have a frequency table and how you actually use it. That would be a lot more useful. So the x is the same, it just means the values again, and f is just the frequency of those values. So let's actually draw up a table. So let's say I had a table where, let's say something like the top one is people's favorite colors. Or let's say, actually, I want to use a quantitative. I want to use something quantitative, not qualitative. So let's just say how many, I don't know, sweets someone has in their pockets or something like that. Or let's say I have a few children and then they'll have a bunch of sweets. So we want to know how many sweets everyone has. And then here we can say the number of students with those sweets. So here we can say there's 12 sweets. Let's say some people have 14 sweets, let's say I have some 16, and let's say one guy had 22 sweets over there. So looking at that, let's just give random numbers here. So like 4, 16, 22, like 10 over there. Okay, so this is like your frequency table that you'd have. So just so you know, this would be your X values and this would be your F value, because the number of students you have is obviously your F is how many students have it. So 4 students have 12, 16 have 14, and so on. So to do this, first of all, let's actually find like the mode, the median, and the mean. So you'll know how to do each of the three. So the easiest one to do would be the mode. So to do the mode, all we need to do is say which one is the most popular out of the number of sweets people have, or how many sweets, do people have the most. So only 4 people have 12, 16 people have 14, 22 people have 16 sweets, and 10 people have 22 sweets. So clearly the number of sweets which is the most popular would be this one here, since 22 people have 16 sweets. So very simply, based on that, we can say the mode is 16 because it's the most popular one. So that one's quite simple there. Next up is the median, which is also fairly simple. So to do something like this, what we need to do, like we did before, is you group the numbers from smallest to biggest, and you would find out which where the middle number is. Now, in your frequency tables, normally the numbers are given to you like smallest to biggest, so you can see this is in ascending order. So you don't need to worry about reordering the table. If they weren't, then you just make sure that these numbers all come in smallest to biggest form, and you just do some reshuffling and whatnot. So for this example, let's see how many total numbers that we have. So how many students do we have in total? We have 4 plus 16 plus 22 plus 10 in total. So based on that, let's take a look at what that gives you. So 4 and 16 is 20, plus 22 is 42, plus 10 is 52. So we have 52 in total. So based on that, we need to take 52 plus 1 over 2, which will give us 53 over 2, which means we need to take the 26.5. So we have to say the 26th and the 27th values in our table. So where does that happen? Well, let's start with this. So 4 carries us into 4, plus 16 means we're in the 20th value. So the 26th and the 27th values lie somewhere in this 22 over here, probably somewhere here and somewhere here. So since they're both values of the 26th number and 27th are both 16 and 16, then that means I can say 16 plus 16 over 2 is 16. So again, just like the mode, it happens to be the case that our median is also 16. So that's fairly simple again to do. It's the same kind of stuff you've done in GCSEs. I think they also do frequency tables in GCSEs. They just don't tend to use all this notation we've used, but it's pretty much the same idea. So I'll get rid of that now, and now let's talk a little bit about how you would do the stuff for how you'd find the mean. So what we've been waiting for in this chapter is how do I use this equation? So the way you use this equation is, let's actually write it out. That's what I always tell my students all the time. Always start by writing this equation at the top first, and then ask yourself what values do you know and what you're trying to find out. So we're trying to find out this value for x, and therefore we need to figure out this one and this one here. So if x bar is equal to that, the easiest one again to figure out is the sum of the frequencies. So the sum of the frequencies is quite simply that plus that plus that. So can't remember what that was again, so let's just calculate that again. That's 20, 42, 52. So our sum of the frequencies are equal to 52. And I did that by doing 4 plus 16 plus 22 plus 10. And now what I need to do is find the sum of x times f. So what is x times f? Well, a nice way to figure out what xf is x is this value here, and f is this value here. So xf, if that's x, that's f, then xf is simply 12 times 4. Then I do the same thing for these two. I do 14 times 16. So at the top, what I'd write is something like 12 times 4, and since it's the sum of all of it, you remember that sum sign there, then I do plus 14 times 16 plus 16 times 22 plus 22 times 10. All of that together will add up to a number. So let's actually figure out what that is. That's 48. And let's just use a calculator for the rest of them. So we have 14 times 16, which will give us 224, plus 16 times 22, which will give us 352, plus 22 times 10, which is 220, all over 52. So the sum of this is equal to 48 plus 224 plus 352 plus 220, which gives us 844 over 52. And if we do that value, we will get a final answer, 52, of 16.23. So to one decimal place, that's 16.2. So we can see that the data is fairly well distributed actually. The average is somewhere around 16, since the mode, the median, and the mean all have similar values. And that's how you use the equation. It was quite simple. If it helps sometimes, if you want, you can also draw another row under here, and you can say like the sum of this is 48, this is 224, this is 352, and this is 220. You can also do something like that if it helps. And then you can just put those numbers in here. But just remember, all I did to get these numbers at the top was 12 times 4 is that. 14 times 16 is there. And this times this is there, and this times this is there. That's all I had to do. I summed all of these up to get my 52. And that was it. So the equation might look a little bit scary or off-putting, but to be honest, pretty much that is the most useful answer. Now, based on all of that, I hope that the mode, mean, and median are fairly simple to understand, and you can do the calculations. And it's definitely worth practicing using this equation a lot with frequency tables, and also doing it on numbers which don't come up often. And there's lots of different variations of the questions. For now, I'll go over the variations of the different questions in another video, but the stuff you've learned so far should help you be able to solve a lot of the exercises that you've done. So yeah, from there we'll move on to the next part. So far we've taken a look at the cases where I have numbers like 1, 3, 5, 6, 8, and so on. Like if you have an example like that, or we've seen times where you might have some sort of frequency table and they tell you about each of these values. So like 1, 2, 10, and like 16, something like that. So you have like a frequency table of some kind. But I want to take a look at questions, and this is the final type of thing you should really know for the mean, median, and mode, which is what about tables where instead of that it has something like 15 to 20, and like 21 to 25, 26 to 30, and so on. So you can see the difference is that here I've got single numbers, but here I've got a range of numbers in between. And that does actually change the way we do our calculations. So rubbing that out, I'll give an example, and I'll be very quick to understand this. So all you do is, let's say we have like the length of a tree. And let's say we have, the frequency of these. And the lengths we'll have are 10 to 11, then 12 to 13, 14 to 16, and let's have 17 to 19. Okay, and let's just put some random frequencies in. So let's put 3, 25, 26, and 15. So there's not much difference when you're doing something like this. So when you're doing something like this, when you have to find the mode, you're not really finding the mode anymore. You say something called a modal class, and this is again the most frequent one. So you can see here the most frequent one to occur is this class here, and that's the 14 to 16 range. So the modal class is quite simply the 14th to 16th one over there. Now the mean that you need to do is quite simple as well. So the mean, the only difference between this and what you had to do before was, since I've got a range here, you just need to find the middle part of that. And to do that, you can just do 10 plus 11 over 2. So the middle of each of these values, this would be 10.5, this would be 12.5, this would be 14 point, actually no, this one wouldn't be, this one actually be 15, and this one would be 18. Once you found the middle part of each of these things, you simply multiply that by this value instead of like these ones. So since that's 10.5, 10.5 times 3 plus 12.5 times 25 plus 15 times 26 plus 18 times 15 all over the frequency once again. So adding all of these up. So adding this up, I get 40 from that. Then I get 66 and 69. So that's your mean. Then simply do the calculation in your calculator and you'll get what your answer is for the mean. So the median is also fairly simple. So in this one, you also need to find something called, so the median, you find the median class. And for this, what you need to do is you add up the frequencies, add 1, divide by 2 to find where your median should lie. So we already know the 69 numbers. So 69 plus 1 over 2 means it's in the 35th number. And where does that lie? Well, here's 3 numbers. This gets us to 28. So 35th number is somewhere in here, which is, again, in this class here. So our median class, once again, would be 14 to 16. That's the answer for that one. That's what the median class is. And hopefully that makes enough sense. And that's pretty much all you need to understand for the mean, median, mode. These are the 3 types of questions you can get. Either you could have a list, you could have a frequency table, and in the frequency table, either you have where it's a single number, or you will have one where you have a class. But pretty much the principle is the same across all of them. And I just hope you get used to using the formula, and that's pretty much it for that. So now we're going to move on to the next chapter, which is how we look at different measures of location. So things like quartiles and percentiles and all that lot of stuff. So like we said before, we've done the mean, the median, and the mode, but there's also other things like quartiles. And actually, the median is an example of a quartile. The median is actually known as the second quartile. So before we actually go through this, let's actually talk about what do we mean by the quartiles. So the best way to explain what quartiles are, so let's call this chapter Quartiles, is we should start with a line. This is our number line. And along this, we're going to mark somewhere roughly 25% across, 50% across, and 75% across. So this is 25%, this is 50%, this is 75%, 100, and 0%. So these are different locations within our data. So what quartiles and percentiles are about. So we'll start with quartiles first. So the quartiles tell you how far along the data that you actually are. So the thing that everyone knows as the median is actually known as the second quartile, and it means that it is 50% of the way through the data. That's why you always order it from smallest to biggest and go halfway through. But you don't always have to go halfway through. Sometimes you might only go 25% of the way through, in which case you're going to be known as the lower quartile. That's what we call Q1. That's when you only go 25% of the way in. And if you were to go all the way to 75%, well, we have another thing for that, known as the upper quartile. So this is known as Q3. And that tells you something where you are 3/4 away through a data set. And then here you'd have your lowest value, whatever the smallest value in the data set is. And this part here, which is at 100, would be your highest value. So somewhere in between your lowest and your highest value, you have a middle number, you have one which is 1/4 of the way and one which is 3/4 of the way. And the different quartiles are just telling you how far you are going through, in each of those values. So you could find, the 23rd quartile or something. Well, we don't really call them quartiles, but how much through you are. But we tend to say lower quartile, upper quartile, and the median. Those are the ones we're really interested in. Now, we also have something known as percentiles. So percentiles are quite easy to understand as well. So let's say I just chose a random number. So let's say rather than using a lower quartile, The percentile, if let's say I went like, I don't know, 27%, then the 27th percentile is just 27% of the way through the data. Or if I had something which is like the 87th percentile, that's just 87% of the way through the data. And all this tells you is if I'm getting the 87th percentile, then it means that 87% of the values are less than this number. So if I chose a number and I found what this was for the 87th percentile, finding that would tell me that 87% of my values would be less than that. Same for 27. The 27th percentile tells me if I hit the 27th number, let's say this was like 10, then 27% of the numbers are less than that. That's what percentiles tell you. So that's pretty much all there is to it. So just like how you know how to find what the median is, there's a simple way to find what the quartiles over there are. So we'll go through what each of these are. So if you want to find the lower quartile, you just have to do the total number of things divided by 4. And for the upper quartile, it's just 3/4 times n, so 3n over 4. So n over 4 would tell you what the lower quartile is, 3n over 4 would tell you what the upper quartile is. And then obviously the median, we already know how to do that. So that's pretty much all you need to know for that. I guess the best thing to do now would be to look at an example. Actually, just before we do take a look at an example, one thing I would like to point out is when you do your median, you do n plus 1 over 2, which is something you'll be used to. But when you're doing the lower quartile and the upper quartile, just notice you don't have that 1 over there. So that doesn't actually come across. So, okay, let's come up with a bunch of numbers then and see how exactly does, this stuff work. So I'm just going to come up with a bunch of random numbers. 22, 24, 26, 28, 28, 28, 30, 32, 36, 37, 39, 42, 46, and 50. So I don't know how many numbers I put there, but we'll go through it. Let's say for, this set of data, we want to figure out quite simply what are the 3 quartiles. What is the lower quartile, the median, which is the second quartile, and the upper quartile, which is Q3. So let's start with this. How many numbers are there in total? What is n equal to? So we've got 1, 2, 3, 4, 5, 6, 7, 1, 2. So we've got 14 numbers in total. Okay, so let's start with the median since we're always familiar with it. So the median mean we do 14 plus 1 divided by 2, which means we have to get the 15 over 2, which is 7.5. Therefore, we need the 7th and the 8th values. So what is the 7th value? I've already ordered it on purpose. So 1, 2, 3, 4, 5, 6, 7. So 30 is our 7th value. What is our 8th value? That's 32. So you add them up, you get 62. So 62 divided by 2 gives you 31. That's our median. So that's pretty much, that's okay there. That's our median, which makes sense. Looking at this data, 31 looks like it would be pretty much, in fact it is pretty much halfway through our data set. Now let's do Q1. So Q1 is pretty simple to do actually. So we just simply do 14 divided by 4. And once you've done that, all you've got to do is, let's take a look at what that number is. 14 divided by 4 is 3.5. So now we've got 3.5. So what we're going to do, quite simply, we know that it's between the 3rd and the 4th values. So the 3rd and the 4th values into 3.5, which is 26 and 28. Same thing as before. Add them up, get 54. So divide that by 2, get 27. So our quartile 1 is 27. And finally, for the last one, 3 times n over 4. 14 times 3 is 42. So I'll just put that here actually. 14 times 3 over 4. So 42 divided by 4 gives us 10.5. So that means we need the 10th and the 11th number since it's 10.5. And the 10th number would be, so 7, 8, 9, 10. So 37. 37, 39 are the 2 values, add them up. So you get 69 plus 7, so you get 76, I believe. Divide that by 2 and you get 38. So your three quartiles are, that's Q1, that's Q2, and that's Q3. So it's pretty much as simple as that. All you need to do is find the value of n, which you can find by counting all the numbers you've got. Then to find Q1, you do n divided by 4, gives you which numbers to look at, figure that out. If that's not like 0.5, if it's just 3, then it's even easier. You just go to the third number. The median you always know how to do, just remember the plus 1 and Q1, Q2. Don't need the plus 1. For Q3, take your n, times it by 3, divide it by 4, and then again get the numbers, and it all works out just as you intend. So hopefully that's useful, and that will help you out. Next, what we're going to take a look at is, I mean, this is pretty simple to understand. It applies the same way if you're doing a frequency table. So we won't go over that because it's pretty much going over the exact same thing, but in a frequency table where the numbers are of this form, where it's like 10, 15, 20, and like 25, and like 1, 2, 3, like these are the frequencies, and like these are, you know, x values, then in that case, you just simply do the same thing. You find n the same way as you did, because you can sum up all the numbers over here and add these up, and then you do the same thing. You can find, you know, which class it falls in. Actually, there's no class, sorry, in this case. It's just straight up which numbers they are, and it's pretty much easy to do that. So nothing too tricky there. However, if I give you a different type of table, which is no longer that type of frequency, but it's like 10 to 15, 16 to 20, 21 to 25, then you actually need to learn a different method to do that. And this is one that you probably wouldn't have had to do at GCSEs, because this is new to A levels. And that's a particular kind of question which I like to go through just to show you a trick you can use to do it. It makes it very easy to understand. And we'll just go through an example where we've got a question like that. So let's try that next. Okay, so here's an example of what I mean by group frequency. So we're going to use a technique known as interpolation to figure out the quartile stuff for this kind of question. So it's called interpolation. What we mean by that is we're going to assume that the data in each of these sets is evenly distributed. So what I mean by that is there's not like a bunch of like lots of 20s and there's a random 21, but I think the data is fairly evenly distributed. So you can see that the chances of something happening here are the same as the chances of happening here. So let's say there's a question here which we need to figure out what is the upper quartile for this set of data. And you'd want to follow these steps very carefully, and I'll show you one by one what you need to do. So to find Q3, the usual way, first thing we needed to know was the frequency. So we add up all these frequencies together. So 4 plus 29 is 33, 33 plus 32 is 65, 65 plus 15 is 80. Okay, so that's quite nice. We've got a nice round number there. So we'll put down 80 times 3 over 4 to find out which value we need to find. So this is how we normally find our quartiles. So 80 times 3 would give us 240, and 240 divided by 4 tells us we need the 60th value. Okay, now we're going to be very careful here. Where is the 60th value? So this would give us 4. This would get us to 33, because 4 plus 29, which means that our 60th value should be somewhere in this class over here. Because if we've already got to 33, then if we add on 32, that'll take us 65. So that means there's somewhere in here. So now we know which class it is. So just based on that information alone, we're going to draw something like this. So let's put down the different numbers we get. So which class was it? We found out that the value was in this class. And what you need to do here, this is the part you have to be careful. Notice this doesn't take into account like 23.5 or values in between 23 and 24. That's because your groups here take that into account. So we don't write 24 or 26. What we actually write is 23.5 and 26.5, because those are the actual boundaries of our class. And we know that our our number, which is quartile 3, is somewhere in between, but we don't know which one that is. And then at the bottom, what we're going to write is a cumulative frequency. So what I mean by that is, where are these two numbers? So this one here is just 4 plus 29. So we start off at 33. And if you then want to come to the other side, which is here, then you've got to add up all of these numbers. So that and that will tell you what that is. So that's 33 plus 32, which would give us 65. So this would be 65. And also we know that, our quartile 3 is the 60th one. So it's a lot closer to, even though I've drawn it like this, it's a lot closer to here than it is to here, but you can just put it in the middle for now. And now we're simply going to use the idea of ratios. So you want to follow this very carefully because you don't want to get this part wrong. So what we're going to say first is, as part of our calculations, is that Q3 subtract this number here. So this subtract this value here, 23.5, over the 26.5 minus 23.5. So what I've done here is I've got this value minus that, and on the top I've got this value minus that, is equal to, so this is where the ratio stuff comes into account. Now we do the same thing for the bottom part. So what we'll say here is 60 minus 33 over 65 minus 33. So that's what we do. So I know there's a lot of numbers which just, got down here, but let's actually look at what we did. It's quite simple. On this side, over here, I'll say do this value minus that value over this value minus that value. And then on the other side, I do the exact same thing. I do this value minus that value over this value minus that value. So the way you do it is you do this minus that, then this minus that, then this minus that, and then this over that. And that's how you get the ratio of how far along your thing should be. So like you can see, there's only one unknown in this situation. So in this case, what do? Well, let's just solve it. So Q3 minus 23.5 over 3 is equal to 27 over 32. So that means Q3 is equal to 27 over 32 times by 3 plus 23.5, whatever that turns out to. Let's put that into our calculator. So 27 divided by 32 times that by 3, and then add 23.5 would tell us that the value we get here is 26.03. So 26.03. So that is what your length would be. You can see that just about fits in for, you might be thinking that's 26 and it ends at 26, but remember it ends over here at 26.5. So that is actually within the values that we were expecting. So yeah, that's pretty much how you do that part there. So hopefully that was helpful. That's how you do Q3. Let's say, now that you understood that, let's actually get rid of the fact that's Q3, and let's actually talk about the percentile stuff that we've done, because percentile stuff is pretty much the same kind of thing. So let's actually figure out how we do that kind of thing over there. So for this, let's rub everything out. Let's rub that out, and let's keep that line there since we'll need it. And let's just get rid of all of this. So now let's say I asked you, could you find me what the 10th percentile is? So, the upper quartile was the 75th percent. Now we're finding the 10th percentile. So just in case you get like a random number, which is not like a lower quartile, median, or the upper quartile, this is how you can do any number. So let's say I had to do the 10th percentile. So the 10th percentile would mean we need to be 10% of the way through our data. So how many sets of data do we actually have? I mean, what was n again? So it was 33, 65, and 80. So 10% of the way through would be 80 divided by 10, which is 8. So it means our 8th value. 8th value falls between, 4, it's not going to be in there, it's going to be somewhere in this one over here. So that means we know what class we're in. We're in this class here this time. So get rid of that. Cool. So since we know that, we'll do the same stuff as before. So what did we do before? We need the 10th percentile, and you write it as P10. That's how you write the 10th percentile. And also now we have to see which class it was in. It was in 22 to 23, so this is 21.5. This is 23.5. Now, let's put the bottom stuff in. So again, these two parts here. So this here is 4 across, and this here is plus 29, so this is 33 across. So this would be 4, and this would be 33. And also we know our value, which we're looking for in the 10th percentile, is number 8. So now following the same equation we did before, we'd say P10 minus 21.5 over 23.5 minus 21.5 should equal to 8 minus 4 over 33 minus 8. So same thing as before, P10 minus that, 23.1 minus that, 8 minus 4, 33 minus that, and that pretty much is all you need to do, and that will give you the answer. So apologies, the video cut out for a little bit. So yeah, just picking up back at where we were, we said the answer for this one would just be solving this equation here. So that's what we've got over here. So let's solve that. So P10 is equal to 2 times 4 over 25, which is 8 over 25, plus 21.5. That will give us P10. So let's just put that into our calculator. 8 divided by 25, and then add on to that 21.5, giving us a final total of 21.82. So as we can see, our final value for P10, probably I would give that roughly as 21.8. That's the value, which is our 10th percentile. And that's pretty much it. So you can pretty much find any number you wanted, to be honest. The only thing I'd say is that, let's say I randomly said you have to do like the 72nd percentile for some reason. Then when you know you have 80 numbers, just times that by 72% to find out, which two numbers you need to look in between. And that's pretty much it, to be honest. And yeah, that's one of the more, it's not very complicated, there's just a lot to follow. Just make sure you're very careful in that. And as long as you're careful, all the numbers should fall out. Should be fairly standard and should be a bunch of free marks in the exam. So now that we've looked at all that stuff, let's take a look at the last thing that we've got left before the main topic of standard deviation and whatnot. So that's something known as the range, the interquartile range and the interpercentile ranges. And you've actually done the hard work for this already by doing all the stuff up here. Because, quite simply, the range is the difference between the biggest and the smallest values. So you just do the biggest value minus the smallest value. And that's it. That would give you what the range would be. And then if you wanted to find the interquartile range, which you call that as IQR, that also quite simply is just the difference between the upper quartile and the lower quartile. You know how to find both of these already from the stuff we did before. And if you subtract them from each other, you get the interquartile range. And the interpercentile range is simply the difference between the two percentiles are given. So let's say you're given find me the difference between the 90th and the 10th percentiles. Then you just do the 90th percentile minus the 10th percentile, and that would be it. So you know how to find these values again from the stuff we've done before. You know how to find the 10th percentile or the other things using all this stuff we've learned up here. And I won't go through a question on this because, to be honest, the question boils down to, can you find these values and subtract them from each other? And you already know how to find those values, so it'll be quite easy. Again, the range is also quite easy. Biggest value minus smallest value. In this case, you just do 39 minus 20. And your range would be 19. We found what Q3 was before. You do the same thing to find Q1 and put together, you would get your final answer. You can normally expect questions like this. So they might give you find the interquartile range because they want you to do what we did up here. They want you to do it twice and then find the difference, and that would make for a nice question which has a lot of marks in it. Same for the interpercentile range stuff. So hopefully, yeah, that helps. And to be honest, that's all there is to it. These are known as measures of spread. So measures of spread, and that's what each of these three things are, your measures of spread. So hopefully, there's not really much to say there, so hopefully that's okay. Just make sure you're comfortable finding each of these values and you'll be good to go. Cool. So now let's actually move on to the more new and the slightly more exciting stuff in this chapter. Okay, so what we're going to take a look at in this chapter is something known as variance and standard deviation. So you'll be shown this the first time in stats during A-levels, something you probably haven't seen at GCSEs. And just a disclaimer, the equation coming up might look like it, scary, it's quite complicated because you haven't seen a lot of these signs before, but it's actually pretty easy to follow. And hopefully if I go through an example of how you would make it work, it should be helpful. And I'll go to a bit of the theory as to what does the variance actually mean, because a lot of people don't really understand what the variance is. They might be able to figure it out, but they're not always the best to understand what does someone actually mean when they're saying, find the variance of this or find the variance of that. They're not very comfortable with that. So I kind of want to explain to you what the variance kind of is. So what is the variance? The variance basically is trying to tell you how the spread of the data is. So how much does it spread out from the mean value? And what I mean by that is the variance is trying to tell me that, or let me give you an example. Let's have a set of 4 numbers, 5, 5, 5, and 5. Or actually, for the sake of this example, 15, 15, 15, and 15. Then I'll choose the 7 numbers, 20, 10, 10, 20. And then finally I'll choose 30, 0, 0, 30. So if I averaged these numbers and found the mean, it would quite simply be 15. If I found the average of these numbers, it would actually also be 15. And also if I did this last set, it would also be 15. So you can see the average of all 3 of my sets of numbers is actually all 15. But the data you can see is quite different. It's spread out quite differently. And what I mean by the variance being how spread the data is from the mean, I mean, sorry, pardon the pun, if I have 15 as a mean, then 15 is pretty much on the dot with all of my other numbers here. But in this case, 20 is quite far away. It's plus 5. This is minus 5. This is minus 5. And this one's plus 5. So this one's a bit, the data, even though my spread is, my mean is 15, my variance will have some sort of number. So here you don't have any variance. Your variance would be 0. Here would be some number, but we'd have to figure out what it is. Let's say it's roughly 5. And then if you're taking a look at your variance over here, then 15 is 15 away from that, minus 15 from that, minus 15 from that, and plus 15 from that. So these values, even though the average is 15, are quite different to 15. Here they're a bit closer, but they're still a bit further away. And here, they're exactly on it. So what the variance is trying to tell you is going to be how far away are your numbers from your mean. So the higher your variance number, and I've just made these up here, but the higher variance number, so I'm just going to make up a number and let's say that's like 15. The higher your variance is, the more spread out your data is from the mean. So here you can see they're not very spread out from the mean. That's why the variance is 0. Here it's a little bit more spread out. So my variance is 5. And here my thing is very spread out, so it's 15. So even though they all have the same means, their variances are different, and that tells you how spread out each of these data points are. So hopefully that makes a little bit of sense in terms of what is the variance. So that's the theory behind it. And so if someone asks you what's the variance, you can simply say how far away each point in the data is from the mean. So now we're going to take a look at the equation for variance. And there are actually 2 versions of the variance, and then we'll take a look at what standard deviation is. Or actually, I'll just mention what that is now, actually. So the standard deviation is actually just the square root of the variance. I might as well just say that now, just so that's pretty much all you need to know in this chapter. So the standard deviation is the same as the square root of the variance. So normally what you do is you'd find the variance and then we just square root that and then we get the standard deviation. So yeah, what is the equation for the variance? Well, there's two equations. Let's take a look at the first one first. So the variance is given by the sum of x minus x bar squared. So x minus x bar is quite simply the x value, take away the mean that you figure out and you just square it. So that's pretty much it. The reason you square it is because if you remember before we had like 5, what was it? We had 20, 10, 10, 20. You know how we were saying that the differences from 15 were +5, -5, -5, and like +5. They all add up to 0 because the -5s and the +5s go to 0. So sometimes you might be above the mean, sometimes you might be below the mean. So by squaring it, you can get rid of that negative sign here. So these would all be taken as like 25, 25, and 25 because you square each. That's why you have the squared there. So yeah, you have the sum of x minus x bar, which is a mean, all squared, divided by n. And that's actually all the variance is, but we can just break that down further because sometimes we don't have that information. So that's the same as saying find the sum of all the x's squared, divide that by n, and subtract the sum of x over n, which you'll recognize this is just a mean, all squared. So this part is just saying sum up or find all the x squared values, add them up, divide them by n, then find the mean, square the mean, and subtract that from whatever you found here. But don't worry, we'll go through an example. And we often write this whole thing as s subscript x over n. And what is s x actually equal to? So s x is equal to the sum of x minus x bar all squared, which is the same as saying sum of x squared over n minus x's squared minus n. So it's pretty much the same thing as saying that. So that's just what sx is equal to. So there's a lot to keep track of, and I'm sure that it seems quite scary at the moment because, as you know, there's a bunch of different numbers and whatnot over here. Or there are no numbers, it's just a bunch of symbols. And you're probably thinking, do I remember this one, this one, this one, or like what do I have to remember here? But don't worry, I'll go through the questions and show you which ones of these you'll use. Just depending on what data you're given, either you'll use like this one or you'll use this one over here. But if you think of it as only really two equations, it's this one and this one. So let's these are the different ways you could write the formula actually. So I said there are 2 ways, there's actually 3. This is 1, this is the second, this is like the third. You can write it depending on what data you're given. So sometimes you can actually use your calculator to find that quite easily. And it's just, it's quite simply just finding this over here. Or you could use this, or you could use this. But yeah, this is the first part of the equation, this is the second, this is the third. Once you found it, and if you square root it, that will give you the standard deviation. So just so you know, another thing is the variance, we call this the variance. That's the symbol for the variance. So if someone tells you to find the standard deviation, that's the symbol for standard deviation. So yeah, kind of to summarize what we've just said is, yeah, these are your 3 equations, and then this is your standard deviation, which is square root. And I think the best way to go forwards from here would be just to give you an example, the same way we did before, how you do it with a list of numbers, how you do it in a frequency table, or something like that, and how you might do it in a grouped frequency table, which is something like that. So I'll give you these 3 examples for how to find the variance and the standard deviation. And hopefully that will get you a lot more familiar with the equations that we have, because with the group frequency stuff, as you can imagine, we'll be putting a bunch of, F's everywhere and stuff like that. So it won't be too bad, but try and keep up the examples. So, okay, let's actually go through and try how to do this. So the first type of question we'll do will be with a simple set of numbers. So let's say 4, 6, 8, 8, 5, 6. So let's say you've got this list of numbers and someone told you, I want you to find the standard deviation of this. So in order to do that, first we'll start off by trying to find the sum of x. That's the first way you'll start off with. So what is the sum of x? The sum of x is equal to 4 plus 8 plus 6 plus 8 plus 5 plus 6, or whatever that is. So this is 10, 18, 26, 31, 37. So our sum of x is 37. Hopefully I got that one right, other than silly mistakes. But yeah, so we've got 37. So the next thing we want to figure out is what is the sum of x squared. Now be careful here, you can't just square that to get this value here. That's not how it works. What you have to do instead is the sum of x squared means first find x squared and then sum them up. So that means 4 squared plus 6 squared plus 8 squared plus 8 squared and so on. So 4 squared plus 6 squared, 8 squared plus 8 squared, 5 squared plus 6 squared would give us something. So this is equal to 16 plus 36 plus 64 plus 64 plus 25 plus 36. So if I just pop all of that into my calculator, 16 plus 36 plus 64 plus 64 plus 25 plus 36, that's 241. Cool. Now we know what x squared is. So like we said with how do we find the variance, we had the equation before, which was this one here. Sum of x squared over n minus the sum of x over n squared. That was it. So if you just pop in the numbers, we know what the sum of x squared is. That's 241. We know what n is because we just count up how many numbers we have. So 1, 2, 3, 4, 5, 6. Minus, and this is just a mean. So the sum of x, like we did before, 37 over 6 numbers, all squared. And that's it. That will give you what your your variance is in this question over here. So if I were to do that, calculate 241 divided by 6 is about 40.12. 40.17, my bad. Subtract 37 over 6 and then times that by itself is about 38, so minus 38. So looking at that, we get 2.17 as our variance. And so our variance is 2.17 and the standard deviation is just 2.17 square rooted, whatever that would give you. And yeah, I mean, whatever that gives you would be the answer to this one over here. I guess I might as well just do that. So 2.17 in my calculator, that's about 1.47. And that's it. When you have a set of numbers, the easiest way to do this would be to use this equation here. Find sum of x squared, find the sum of x. N is easy to find, and like you can see, you quite simply just pop in the numbers and everything falls out. So hopefully it seems a little bit less scary now. What did we do? We found the sum of x, found the sum of x squared, and remember the way we did it. We didn't just square this number here, but no, we squared each of these numbers and then added them up. If I said the sum of 3x, then what you do is you do 3 times that, 3 times that, 3 times that, and you'd just add up all of these numbers with each other. That's what you do. So the thing inside the sum, like if it's 3x plus 2, just tells you what to do to each number, and then you do that to every number and then just add them up. So 3x plus 2 means do 3 times 4 plus 2, do 3 times 6 plus 2, and so on. That's how you can work with sums. But yeah, when it's a simple list of numbers just like that, then pretty much that's it. That's all you need to know. So from that, let's actually move on to doing frequency tables where the numbers are fixed. So for something like that, the variance is actually equal to, it's a similar thing to what we did before, but now I'm just going to put a bunch of f values in for frequency. So f, and what I'll do actually is I'll put them in red to show you the difference. Because you can see all I've added is a bunch of x's. Everything in black is the same as what you would have done before. So this will be the sum of fx over here. Sorry, not sum of x, sum of f. Then just trying to remember what it was. Equal to the sum of f squared, sum of f minus, oops, just put that in red, x over sum of f. And oh yeah, I should probably put that in red. Sum of f, sum of f over there, then that's in brackets squared. So it's pretty much the same equation as before. It's just I've got, instead of all the, I've just added, instead of n, I've got sum of f, and then I've added a few f's on the top. But that's the equation that you would use for doing the variance in your tables. And then again, the standard deviation is literally just, this is literally just equal to all of that's square rooted. So I think the best way to do this would be to probably just do another example. So let's do the usual thing. Let's say length, let's say frequency, and let's just put a bunch of lengths into 25, 26, 27, 28. Then let's put in a bunch of frequencies. So like 4, 18, 25, and 30. So these are your values. So if you had a table like this, then it's pretty simple again. So you start off by finding the sum of fx squared before you started off by finding the sum of, fx. So you can also do that actually, but it doesn't matter which order you want to do it in. So actually, let's do that. Let's stick to what we did before. Before, we found the sum of x. Now we'll find the sum of fx because your frequency table. That's quite simple. You just multiply each of these values and then add up what you get. So sum of fx, and I'll write that out in full. It's 25 times 4. You can see how I got that just from there. Plus 26 times 18, plus 27 times 25, plus 28 times 30. Whatever that comes out to. So let's just put all of those into our calculator once again. 25 times 4 is 100, plus 26 times 18, which is 468, plus 27 times 25, which is 675, plus 28 times 30, which is 840. So if you add that all up into your calculator, you get 100 plus 468 plus 675 plus 840, which is 2083. Cool. That's the sum of fx. So in our equation that we're going to use, we found this part here. Sum of f is quite easy, so we might as well also do that. The sum of f, put that here on the side, is just 4 plus 18 plus 25 plus 30. So that plus that is 22, plus that is 47 and 77. So that's what we should get over there. That's our sum of frequencies. So we found that one, we know that one. What does that leave us with? Just this one here. So how do we find the sum of fx squared? So that's also quite simple to do. So x, remember, is this part over here. So we have to do 25 squared. So you do 25 squared times 4, 26 squared times 18, 27 squared times that, and that times that. So it's quite easy. If you imagine what we wrote here, it's actually the same thing. So I could even copy all of that. It's the same thing as that, but the only difference now is the x's are squared. So instead of doing fx, like you can see here we did, this is the x, this is the f. Now since x is squared, that's just squared. So this becomes just 25 squared, 26 squared, 27 squared, 28 squared. And yeah, it's a bit of a headache because you have to actually calculate these values and there will be some huge numbers, but don't be worried, it doesn't mean you're wrong. That's just how you do it. So times that first one gives you 2500. 26 times 26 times 18 give you 12,168 plus 27 times 27 times 25, which is 18,225 plus 28 plus 28, or times 28 times 30, which is 23520. Cool. So now let's just add all of those up. 2500 plus 12168 plus 1, can't tell what that is now, but I guess it was an 8. 18225 plus 23520. So that gives us 56413. So what you can see now is that it is quite a big number, but don't worry about that. Like that's pretty much what it should be. So now you just simply put it into the equation that you knew before. So the sum of fx squared was this value we just got. So our variance is quite simply 56413 over the sum of our f's, which is 77, minus, in brackets all squared, that sum there, and 2083 there. And then I won't put that into my calculator for now, but whatever you get for this in your calculator would give you your variance, and then if you square rooted that, you would get your standard deviation. And that's pretty much how you do this kind of question when you're trying to solve it for a fixed frequency table. Now, for the very last one, it's the kind of table where you have classes, and I won't step through the whole thing because it's actually pretty much the same as the equation is the same. It's just that when you have classes, so let's say I had like 10 to 15, then 16 to 20, and then I don't know, 21 to 23 or something like that, then, and you have some frequencies. This is pretty much the same as what you did before, but instead of taking 10 to 15, you need to find the midpoint. So your f or your x values would just be the midpoints. So what I mean by that is, or let's not do it like this, let's just say, let's do it in a different color. So let's say in green. So the midpoint of this one would be 12.5. The midpoint of this one would be 18, and the midpoint of this would be 22. So you kind of find the midpoints, and then you just kind of use those as your values. So I use 12.5, 18, 22, then 10, 15, and then 20. That's it. And then you do the same thing as you did above, and then you can find your variance and standard deviation. So the only key thing is you need to find the midpoint of the table, and once you found the midpoint, then you're pretty much done. That's all you need to do. And then you can do the same thing. So sum of f's would be like 10 plus 15 plus 20, which is 45. Sum of fx would be 12.5 times 10, 12.5 times 10 plus 18 times 15 plus 22 times 20, and then the sum of fx squared would just be 12.5 squared times 10 plus so on, like, you know, the rest. And then you put that into your equation like before, and that's pretty much it for standard deviation and the variance. And so you can see it's not so bad, even though there's lots of equations. To be honest, the only ones we really tended to use, if I go back a little bit, would be this one over here. So we use this one here and the same one for the fx stuff. So don't worry about the sx stuff at the moment. I'll go through a few questions and stuff later where you can use that. But normally what you'll be given in the questions that you'll do when you're solving standard deviation is pretty much just, you might just be given these straight up, which is great. You can just put them in the equation. Otherwise, they'll give you the table, and from that table you need to figure out. But if you've got the information, then it's very, very easy to do. So my tip would be, write out this equation. Either you've got these numbers or they're given in a table, and figure them out, put them in, and should be okay. It's a little bit fiddly, but you'll get used to it with a couple of exercises. So hopefully that was useful. Cool. So now that's done, we're going to move on to something which is called coding, and that's the final part of this chapter. Okay, so when it comes to coding, a lot of people tend to find this quite difficult as a topic, but it's not a very long topic, and there's a few examples we can go through. Two different examples to hopefully help you figure out how it works. But I'll try explaining just like I did with variation and standard deviation, like what is the actual idea behind coding, and you can learn how to do it, but why do we actually do it in the first place? So coding is kind of like this concept where, let's say I had a set of data, right? And let's say my data was huge. Let's say I had like things where I had a lot of numbers which are huge, and then I wanted to find something about these numbers. To find these numbers, I'd have to do a lot of computation, let's say, because let's say these are like millions of digits long or something. That's very hard. And that might give me some sort of, final answer for some sort of mean. But then rather than spend the whole time to figure out and crunch these numbers and, go through a lot of pain because they're very big and very difficult to work with, why don't I just code them into something easier? So your code, using this code, make it into something easier. So maybe turn this into 15, 16, 18. And then from that, I can find a coded mean. And then from my coded mean, I can just convert back to my original mean. So what's happened here? So I had some data which is really complex and really hard to work with, or took up a lot of space in my computers, let's say, or just very hard to work with in general. Then I came up with some sort of code which made it easier and converted it into its translated form. And now since I found the coded mean of this easier form, I could then convert that coded mean to find the original mean of my data. So what I've done from here is just use a code, simply found a new set of numbers, got the coded mean, and then found my original mean. So that means I hadn't had to go through the pain of crunching this, and I can actually instead do it through computing the same stuff on an easier set of numbers. That's kind of the idea behind coding in a sense. The key thing here is that when you do code your values from here to here, this code doesn't lose information, because if you lose information, then you can't really convert back into the original. So this code needs to preserve all the information, get your coded mean, and get your original mean back. But that is kind of the idea behind how coding works. That's why you do coding, because a lot of books don't really mention why you do it. They just tell you what the equations are, and a lot of people tell me like, cool, but don't get it in the first place, and why do I do it? So this is why you do it. So just going down, let's actually take a look at what is the equation for coding. So when you want to code your values, it's y equals x minus a over b. So let's talk about what are these actual values. So the y values are basically going to be your new coded values. So your original data set, this will be from your original data. The x values are from that. You put that into your original data, and then a and b are just set parameters. They're just numbers which are usually given. So they'll tell you what like a and b are. So to basically code your data, if I gave you like 10, 15, and 20, and so let's say a and b were like some numbers, then I just put in 10 into here, then minus a over b. That would give me my value of y. That would give you your coded value of y from there. So something like that. But if we're doing an example, that would make a lot more sense. But this is the equation. It's just x minus a over b. That gives you new values. And then the mean of your coded data is just given by the mean of your original data minus a over b. So the idea is that I use this formula to turn every single number into a coded set of numbers. Then I find the mean of that coded set of numbers to give me this. And then since I know a and b, because they're the same a and b as here, I can just rearrange this formula to find the true mean from the actual thing. So that's pretty much how you do that. So that's how you can find the mean. And also you can also find the standard deviation of the coded data. So the standard deviation of y, the same way as we have the stuff here, or the mean of y here, the standard deviation of that data is just equal to the standard deviation of the original data over b. So if you know what this is, times it by b, and that gives you the standard deviation of your original data. So these are your equations. I just remember this one, and this one. And let's actually just use an example, because that's the best way to to understand how this works. So going to a new page. Let's say I have some numbers, 232, 255, 206, 217, and 240. So these are some common examples which are often given in textbooks and stuff like that. So you should be following examples which you've got. So if these are your numbers and then I give you the coding, let's say my coding is x minus 200 divided by 10 is the coding that I have given you to use, then quite simply what you do is to find the coding of this data, you just put them in. So you put in these values all into there, and then you'll get it. So what's the first one is 232 minus 200 over 10. So that gives you 32 over 10. So that gives you 3.2, and so on. So if I do that for all these numbers, I get 5.5. I get 6 over 10, that's 0.6, 1.7, and 4.0. So that's my coded data. So now that I've got that, we'll say, can we use that to find the mean and the standard deviation of the coded data? So for the coded data itself, if you were to add up all of these numbers, let's start off by trying to find the mean. So the mean is just the sum of x over n. In this case, the sum of x is 3.2, so 5.5 plus 0.6 plus 1.7 plus 4.0, all over, well, there's only 5 numbers in total. So if you do that into your calculator, again, it would seem we've got 3.2, 5.5 is 8.8, 9.4, 11 point, let's make sure I've done this right. So 3.3, 1.7, 4.0 should turn out to give you a total of 15, it would seem. Let's just try that out, calculator. 3.2 plus 5.5 plus 0.6 plus 1.7 plus 4, yeah, 15 over 5 gives us 3. So our coded value, our coded mean is 3. Now, can we find out what our coded standard deviation is? So that's what the question wants us to know. What is the standard deviation? Well, for that, we know that we always start by finding the variance of the data. So since this is what we've got to work with, how do we find the variance? Well, same thing as before. We said you find the sum of x, which we knew is 15, or let's call it, since we're finding the coded data, I think it's better to call these values x, since the original values is to call them y. So the sum of y is 15. What is the sum of y squared? Let's just quickly figure that out. So it's 3.2 squared plus 5.5 squared, and so on. So doing that would give us a total of 59.74 for all of the data that we've got over here. And so you just put that into the equation. So putting that in the equation, we get 59.74 over 5 minus 15 over 5, which we already did above, all squared, which will give you a total value of 2.948. That's what you're going to get. So that's the value of your variance. Just remember, people tend to find the variance and forget to square root of a standard deviation as the last step. So just remember, you have to square root this now. And that gives you a standard deviation of 1.72. So that's how you can find your coded one. But now that we found this, we want to use our coded mean. So I'll put these in green, and the coded standard deviation to find the original data's value. So for the original data, we said the equation was y bar was equal to x bar minus a over b. So we just put the numbers in that we know. So y bar is the coded mean, which is 3, is equal to x bar, which is the original mean, which we want to figure out. A, like we know from before, it's just 300. B was just 10. So we get 30 is equal to x bar minus, 200 was it? that's 200, and 230 is equal to x bar. So that's how you find that. And at the same time, we wanted to find the standard deviation. How are you going to do that? Well, we know that this was the equation we're working with. So what is standard deviation y? It's 1.72. Standard deviation x, no clue. Divided by 10. So standard deviation of the original data is just 17.2. 10 times 1.72. And that's it. That's all you need to do to find the coded values. So hopefully that was okay. What we did was we just found what the code was first. So we found the new set of numbers, found the mean and standard deviation for these, and then using this method here and this one here, we just put in the values we knew, and that gave us the new value here. Put in the values we knew, gave us the standard deviation there. And that was pretty much all we had to do there. So it'll be worth just going through perhaps one more example, because sometimes you're not just going to be given like the numbers, sometimes you're going to be given these actual values themselves, if you know. So you're not going to be given the numbers, and it's a good way for us to show you how to use like SXX and stuff like that. So let's say you have some code, and the code is given by, the code for H is g minus 5 over 10. So it's the same example that many people often have in their books, and I'll just try and explain that. So, and they've given you the SHH is equal to 43.58. They've said that H bar is equal to 2, and they've said that N is 61. So this is probably the same example you've got, and I just want to explain how that works. So when you've got this, let's say they want you to find the mean and the standard deviation from this data. So in order to do that, it's a lot easier than the last one actually, you don't have to do much working out. We know that the coded mean is given over here. So we can just say 2 is equal to the original mean of the data that we can get. So the original data will be whatever that is, the mean of the original data, minus 5 over 10. So therefore, if we do this, we get 20 plus 5. So the mean of the original data must equal to 25. That was it. Quite easy to do that, not very difficult. And now let's also use this data to figure out the standard deviation. So if you remember from before, we said the standard deviation was the square root of the variance, and the variance was SXX over N. So here all you actually have to do, since we have SHH, so let's put that in, is 43.58 divided by N, just all square rooted, and that gives you 0.845. The equation told us that the coded standard deviation is equal to the original standard deviation divided by B. So we have all those values here again. This one here is 0.845. We don't know the original value, and divided that by B, which in this case was 10, tells us that the standard deviation for the original stuff compared to the coded one was 8.45. And that is pretty much all you need to do. And that's how you can answer this question if you've got this stuff here. It's very easy if you've got that. It's literally just like plug and play. You just put in the numbers which you need, and everything just works out. So this is a coded mean, so that goes here. You've got A and B, that's the original value. Just remember what the different things mean, but that's kind of how you follow through it. So hopefully coding is also quite easy. So this is quite a long chapter. There's quite a lot of calculations we had to do and whatnot, but hopefully that made more sense to everyone. And if there's anything you're not sure about, if there's any exercises you're stuck with, just let me know which ones those are in the comments below. Or if this video was helpful, it's really nice if you could, comment, subscribe, and like on these videos and the channel, just because it makes it a lot easier for me to create more videos if I know a lot more people are watching it. So yeah, that would be very helpful. And just share these with anyone who's stuck, because I'm pretty sure there's not much like this out there on YouTube, which is very specific to the courses that people do in A-levels, and I wanted to kind of go through the chapters that teachers don't really explain that well. So I'm trying to go through all the chapters, explaining every single example and exercise and every type of question that you can expect to have. And then once I've finished the series, I'll move on to just doing purely questions and how to answer every type of question from the different exercises. But in the meantime, just share these around with your friends. And yeah, I'll see you in the next video.